Here's problem 2822. What is the potential difference VB minus VA for the circuit shown? To solve this potential difference between point B and point A, we need to find the currents first. So let's do that. Let's mark our batteries first. So we have a 10-volt battery here, positive and negative, for the long and short bar, and a 30-volt battery, positive and negative, for the long and short bar. Our next step is to assume current directions, and we're going to let our batteries help us out. In the first branch, which has a 10-volt battery, I'll go with the direction of the battery, so my I1 will go like this. And then for the second branch, I'll go with the battery, so my I2 will be going up like this. And then I have to think about the third branch because there is no battery there. Now, since the second branch has a 30-volt battery, it's very likely that I2 is a larger current than I1. And I2 is going into this junction on top at point A. I1 is leaving. So I'm going to need something to supplement I1 because I2 is bigger. So I'm going to need another current exiting that junction. So my I3 is going to come out of that junction like this. I could be wrong, but as long as I'm consistent, I'll be okay. So according to this, going into this top junction, I have I2 is equal to I1 plus I3. And that will be my first equation. I can also think of it the same as if I were looking at this junction down below, where I1 is coming in from the left, I3 is coming in from the right, and I2 is exiting up. So I1 plus I3 equals I2, same equation. So it doesn't matter which junction I choose. Okay, so now I have my current directions. Next step is to mark my resistors according to my current directions. Since I1 is going into the 10 ohm resistor on top, on the right and exiting on the left, we'll have a positive on the right, negative on the left. I2 is going positive into this 10 ohm resistor and then leaving on the top, negative there. And then I3 is entering the 20 ohm resistor on top, positive there, and exiting on the bottom, negative there. So now everything's marked and we're ready to go. Now we want to find I1, say. So in order to find I1, we want to choose the loops that have I1 in them. That would be the left loop and the outer loop. So those would be the two loops we choose. So let's do the left loop. And choosing a starting point, let's go clockwise around this left loop. So I'll enter that 10-volt battery. I have 10 volts minus 10 I1 plus 30 minus 10 I2 equals 0. I want to solve for I2 in terms of I1. So I have 10 I2 is equal to 40 minus 10 I1. Divide both sides by 10. I2 is equal to 4 minus I1. Alright, so there's one equation. I have I2 in terms of I1. Now I want to get I3 in terms of I1, so I'm going to do the outer loop. And I'm going to start from the same spot. So the first thing I'm going to go into is that 10-volt battery. So I have 10 volts minus 10 I1. And as I proceed around, I'm going to enter that 20 ohm resistor, positive, plus 20 I3. And then I'm back to where I started. So that equals 0. I want I3 in terms of I1, so I have 20 I3 equals 10 I1 minus 10. So I3 is equal to 0.5 I1 minus 0.5. So now I have I2 and I3 in terms of I1. I can plug them into that first equation and get one equation with one unknown. So since I2 is equal to I1 plus I3, we have that 4 minus I1, which is I2, is equal to I1 plus, and then I3 is 0.5 I1 minus 0.5. Put all the I1s together and all the numbers together, so I have 4.5 is equal to 2.5 I1, or I1 is equal to 4.5 divided by 2.5, which would be 9 divided by 5, or 1.8 amps. Since we've gone this far, let's find the other currents just for fun. I2 is 4 minus I1, so that's 4 minus 1.8, which would be 2.2 amps. And I3 is 0.5 times I1, 1.8, minus 0.5. So that's going to be 0.9 minus 0.5, or 0.4 amps. Alright, so those are our three currents. We want to find VB minus VA in our original circuit. Let's take a look at what that circuit was. We had a 10-volt battery, like this, 10 ohm resistor up here, a 30-volt battery here. We had a 10 ohm resistor here, and let's see, a 20 ohm resistor on the far side here. And I think that's it. And the way they were marked, positive, negative here, positive, negative here, it was positive, negative here, positive, negative here, positive, negative here. And here's point B, and here is point A. So if we want VB minus VA, we just need to walk our way from B to A. And one way to do it, at least the easiest way, would be to walk all the way around like this and only go through that 20 ohm resistor like that. So if I did that, I would get that's equal to a negative 20 I3. And so that would be equal to a negative 20 times 0.4, which will give me a negative 8 volts. If I tried a different direction, let's just try what would happen if I say went this way. Then VA minus VB would be equal to a negative 10 minus 10 I1 and that would be I'm sorry, I got this battery confused. It was the other direction. So it was positive like this, negative like this. So this would have been a positive 10 minus 10 I1. So that is 10 minus 10 times 1.8. And that gives me also a negative 8 volts. So I can't go wrong. I've got it right. The voltage difference between B and A is a negative 8 volts, and that's our answer.